is a handy way of obtaining a list of useful first guesses when you are trying to find the zeros, or we would say, can say roots of a polynomial. Okay, so let's say that we have a polynomial. Let's look at this first example here. F of x is equal to x cubed plus 2x squared minus 5x minus 6. And I have here the rational zero theorem provides us with a tool that we can use to make a list of all possible rational zeros of a polynomial function. The theorem gives all possible rational roots of a polynomial equation. And to do that, you have a formula to find all the possible rational zeros. Now, when we talk about zeros, remember from Tuesday, or the last class, when we talked about all possible zeros, we were talking about all the possible zeros that were on the x-axis. You know, so it can cross, it can, touch, but all the possible zeros on the x-axis. It may not just be, it may be kind of hard to find all the possible zeros. So we have this particular formula to find it. Or not particular, but this formula to find all the possible rational zeros. How do you find it? Well, here's the formula. We're looking for factors of the constant term over the factors of the leading coefficient. And I didn't write factors, but you still have the equation that's there. So if I want to find all the possible zeros for this equation here, we're going to set our equation where, what is our constant term here? Constant term is the number, it's just a number. So your constant term is the -6. That is your constant term. What is the leading coefficient? Is 1. Why? Remember, we said the term that has the highest degree is the term that has the leading coefficient, which is 1. So we would say, now, when we're saying all possible values, we're looking, okay, here again, factors of -6 over factors of 1. When we talk about all possible factors, it's not just the positives. We also want to look for negatives. So what are factors of 6? Let's just do in general. What are factors of 6? 1, 2, 3, 6. These are all. So since we're looking for all possible rational zeros, we would say positive plus 1, positive or negative 1, positive negative 2, positive negative 3, or we can say plus minus 6, all over plus minus 1. Therefore, we can divide this 1 into each of those factors that's in the numerator, and we're saying plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So right now, we're just using this test to list all the possible rational zeros. Okay? One more example and we'll call it a day. Okay? That is it. We're not going to do anything else just yet. We'll build upon that. Okay? But right now, just being able to find from the rational zero theorem, this is how we use it. Letter B. Here we go. We have f of x is equal to 4x to the 5th plus 12x to the 4th minus x minus 3. What is the leading, what's the constant term? -3. So we're looking for all factors of -3 over our leading term, which is what? Leading coefficient, excuse me, 4. So we're going to list all the possible factors of -3. Plus or minus 1, plus or minus 3. All the possible factors for 2. I said 2. I'm looking at 2. 4. Plus or minus 1, plus or minus 2, plus or minus 4. So let's go ahead now. If any of these, your rational zeros, end in a fraction, do so. What I did was I took the 1 and divided into each term. Take the 2, divide it into each term, or excuse me, each number, not term. And then take the 4 divided into each number so we can find all the possible rational zeros. So we have here, of course, plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3 over 2, plus or minus 1/4, and then we have plus or minus 3/4. Okay, and we'll talk about this a little bit more next class.